Hello. Let me switch to the bigger screen. There you go. So hi guys, I hope you all are good. I hope you all are doing awesome. And let me check the stream. Alright. Looks like it's all good. So yeah, today I am gonna go into the source code of Postgresql as well as follow uh, the documentation they have and try to get as much detail as possible as to how exactly Postgres works, how exactly it takes a SQL query you write and then it converts that query into your results and how it runs everything. So before we get into the detail, Teach Me Database, if you're new here, it's all about teaching you the in-depth, full-on details about databases. Of course, I don't know everything, but I try to share what I know, and it also helps me research more because I like to teach you guys, and for that, I have to, get good at it first, right? Um, Apart from that, I had not been able to create screencast for a few months, and the reason was because I moved to a new city and my job just got really crazy, like hectic. So I'm trying something new, and it's gonna be more of a live video, and you know I will be uh, try to do a live video session every 2 weeks. And one of the reasons because I hate editing, all right. But I do like coding, and I do like sharing with you what I know, right, and learning with you. Give me 1 second. Okay. So yeah, since it is a live video session, it's gonna be, it's not gonna be polished. You're gonna see all my idiosyncrasies. uh, but yeah, at the end of it, we gotta learn something cool. All right. Okay. Enough of the chat. Let's switch to the learning video. Learning screen on my OBS, and then we can go from there. Alright, so over here I have Postgres 13 documentation open, and this is the overview of PostgreSQL internals. So if you go to the documentation, you're going to see they have overview, we have server administration and everything, and then we have internals. And this is what I'm interested in, how a query works, like what exactly happens when we write a query and we click enter or we click hit or whatever, how what starts from there and how it proceeds. Okay. So all right, let's just go through the documentation. If hand in hand, I have also opened this PostgreSQL source code, kind of like proxy. And this is hosted by Doxygen, and the link is in the bio. Not the bio. I'm in the description of this video, this live video, and also other videos that you can go check it out. So this is all written in C, because Postgres actually was written with Lisp in the start, I think. Yeah, but then they started using C. Yeah, as per my knowledge, it's in C now, and there has been no change really. With respect to the language used. All right. So how a query is implemented, and like what happens afterwards. I also have the whiteboard behind me. When we're gonna do whiteboard sessions, I'm gonna switch to the bigger screen, and we can think about we can do mental mapping and learn from here. So alright, get started. The path of a query. This chapter gives an blah blah blah. You should have an idea of how a query is processed. This chapter does not aim to provide a detail. This chapter does not aim to provide a detailed description of internal operation of Postgres, but that's what we're gonna do. We're gonna go and take a look into the source code, and we're gonna try to understand in detail what exactly happened. But it's gonna be helpful. This document is gonna be helpful nonetheless. By the way, if you feel like I'm looking somewhere else, it's because I have flipped my screen, my camera, so that what I write on my whiteboard is visible to you. But anyway, don't worry too much about it. So the path of a query. Let's start here. Here we give a short overview of stages or blah blah blah. A connection from an application program to the PostgreSQL server has to be established. Okay, so let's start over here. We will do a sequence diagram, and we will try to trace exactly what happens in PostgreSQL. Okay, so I can start from left. I think this you can see, right? So we can start here. Okay, we have client, you can see, right? Okay, client, application. Okay, it could be a client application, or it could be anything else which is trying to establish a connection with PostgreSQL server. Okay, so if you have done sequence diagram, you know it will be sequences, so we need this, and then we have PostgreSQL. Okay, what is a PostgreSQL really? I mean, when you install PostgreSQL, right, on your MacBook, you will see a process named PostgreSQL, right? So let's actually take a look into the process itself. I'm not gonna go into a lot more, like, actually, yeah, let's see. So if I go here, my apologies. Okay, there we go. So if I go here, and my data grip is running, so you know the connection is all established. So the Postgres daemon, the PostgreSQL main process which starts everything is running. So if we want to see that, it's what we can do is we can do like process ps, and then we can search for a grep, right? We can do a grep on Postgres, PostgreSQL, and you can see like there is a process running at 8 process ID is 84110, I guess. Alright, so this particular process which is running, which you can see in your MacBook processes, let me see if we can, process manager, what was that? I'm forgetting. Do you guys remember? Like, how do I check the list of all the processes? Well, can I not just do PS maybe? No, not PS. Okay, let's see what PS, what we could do with PS. Okay, oops, maybe H, E, help. PS option requires an argument PS. Okay, cool. PS PID something. Okay, I'm gonna do an old I age-old Google search. Mac C list of all processes. Okay, let's see how to list. All right, let's take a look into Stack Exchange. How do I think it's PS aux. Shit. And also activity monitor, right? Okay, cool. Let's go to activity monitor. All right, so CPU, memory, blah blah blah. We have, let's see, Postgres. There we go. So all these processes, right? And what the hell PID really gave me? Well, if I do px aux and then I'm gonna do a grep on. So I'm doing ps aux and then I'm piping it to a grep operation on PostgreSQL. What it's gonna do is it's gonna ps aux is gonna give me a list of all the processes as we saw, and then grep Postgres is gonna do a grep, which is string, like mainly matching on the input with what you provided, which is Postgres. So okay, this is right. All right, cool. So we have process running here. The PID is 1910, like this one, and sorrow, blah blah blah. There is this one. Okay, so I think this is the main. Okay, this is the main Postgres process. So here we give a short overview of the stages. A connection from an application program to it has to be established. Okay, let's go to. I'm moving ahead, but the reason is because I want to show you something. So Postgres is implemented using a simple process per user client server model. Okay, there's a client, and then there would be a server, which is the Postgres server, and it also uses TCP/IP. In this model, there is one client process connected to exactly one server process. As we do not, so remember this. In this model, there is one client process connected to exactly one server process. So what it means is whenever your client application or just your you in your data grid or Postgres using terminal, right? If you try to make a connection, the main Postgres server process right here, what it's gonna do is gonna create another process. Okay, it's gonna spin off another process, and then once that new process, it's gonna be processed with a PID, and then this will act as a server, and now it will connect to, now this application will connect to this particular process, and then this process will be the one returning anything back. Okay, so the master process, I should say, not server, the master process is the one responsible for invoking creating a new process for each connection. Okay, so that's what this is saying here, that in this model there is one client process connected to exactly one server process. As we do not know ahead of time how many connections will be made, we have to use a master process that spawns a new server process every time a new connection is requested. The master process is called Postgres and listens at a specified TCP/IP port for incoming connection. Whenever a request for a connection is detected, the Postgres process spawns a new server process. The server tasks communicate with each other using semaphores. Semaphores are mainly, you can think of semaphore as a boolean, which is set by multiple processes. So if it is being utilized by somebody else, others have to wait and wait for acquiring the lock. The server tasks communicate with each other using semaphores and shared memory to ensure data integrity throughout concurrent data access. Okay, cool. Let's get back to our whiteboard again. So this gives us a bit more detail. Okay. So what it's saying is, if our client is there, let me use another color. I've got a bunch of these. Okay, maybe I should use green. Alright, so let's say here is our client, and the client makes a request on the PostgreSQL master process. Okay, this is PostgreSQL master. The right way to go about it would be like here. So this will create another process. Okay, and PostgreSQL process. Okay, so the master will create this process. Okay, and then this process would be the one accepting. So we should not actually use this one. This process would be the one which will be accepting this request. So in a way, I should say the request is done on this process, this new process created, and the response, okay, response is made by the created process. Okay, one more thing to keep in mind is the protocol used by Postgres master to listen. So there is a port open. Normally it is 5314. Let me take a look at data group. I think it is 5314, but hey, there's no harm in checking. Okay, there we go. Data source, Postgres, localhost. Oh, 3306. Oh, my bad. Is it localhost? Oh, it's failed. Oh, I'm doing my SQL. My bad. Sorry. Let's go to Postgres localhost. Okay. Yeah, 5432. Oh, so MySQL does kind of similar on 3306, while Postgres does it on 5432. Okay, cool. So yeah, Postgres, this one is using TCP/IP protocol, and the port is 5432. Sounds good? Okay. So, having said that, let me see. One second, I'm checking something here. Yeah, all right, cool. All right, so the master process is called Postgres and listen at a specified blah, blah, blah. Whenever a request for a connection is blah, blah, blah. The client process can be any program that understands Postgres described in chapter 52, and this is like a separate one. We will take a look into it afterwards. But yeah, there could be over here there could be a client application using a JDBC driver, or there is a C as well, libpq. Yeah, libpq as well, it could be utilizing. All right, so those drivers code can also be found in the source code we would be taking a look at. Okay, let's keep moving here. Once a connection is established, the client process can send a query to the backend. Okay, cool. The query is transmitted in plain text, that is, there's no parsing done in the front end. The server parses the query, creates an execution plan, executes the plan, and returns the retrieved rows to the client by blah blah blah. Alright, I'm gonna go back to the previous one because we wanna see the first, follow the brief, the introduction. Okay, so a connection from an application program to Postgres has to be established. The application program transmits a query to the servers and wait to receive the result back by the server. Alright, so you have a libpq or you have a libpq or JDBC powered client application which is gonna trigger Postgres master processes way of handling requests, which is spinning off another process. And remember, Postgres, as it says, will always have one client to one server. That's why when you are on Heroku, there might be or whatever configuration you have set, maybe AWS, I don't know, whatever is hosting your PostgreSQL. Sometime you will get 20 connection, and you will be like, oh, connection. I guess you can't see this. My bad. Let me rewrite this. That's the whole thing about live. I will make mistake, but I'm gonna correct it as well. Okay, so there is a connection limit. Okay, that's the reason. Let me draw this line so I will be sure. There is a connection limit. And the connection limit, sometime I have seen it being 20. So the reason of why that connection limit happens is because at one time, as the plan you have provisioned, there could only be 20 of these processes created. Okay, and remember what it says, that every Postgres connection request has to be handled by one process. So the master process is going to create one process, and if there is a limit on the connection, that is, if there is a limit on how many processes a master can create at a time, that means a new request will be dropped. Okay, so that might be that is the reason why sometime when you get a connection limit reached error, there's like the request fails, because the provision is for only 20 and there's like no more processes can be provisioned by the master PostgreSQL process. Okay, it's listening on TCP/IP. All right, let's keep moving and let's keep building our diagram. So actually, before I move into the detail more, I'm gonna do a small promotion. For these diagrams, when you see, like, I have a whiteboard, but I also use these kind of notebooks, and this is available on Amazon. And yes, I created this notebook, and it's available on Amazon. So the good thing about this notebook is that this is engineering daybook. If you take a look, engineering daybook. Okay, you can have your number, like daybook number 1 or whatever, and you can have like belongs to and everything. And yeah, the good thing I like about this is like for investigation like this where this could go like way further down, like it could go sideways. This kind of notebook, this custom notebook is gonna help you get like the whole diagram, the whole schema, the whole flow chart and everything in one page. And also what I like about this is the reason why I created it, because I also like to fold my notebook and make sure it's not too long, so I can fit it in my pocket. Okay, so I can fold it, yet I'm able to take all the main notes I normally take, long notes and everything. But yeah, hey, it's available on Amazon. If you guys are interested, go buy it. I will make, I guess, 60% or 50% royalty or something on that. Anyway, I like that notebook, so I'm promoting. If you don't like it, don't buy it. It's fine. Okay, let's keep moving. But anyway, if you buy, it's gonna help me. So buy. Okay. Let's move further. So I do wanna now take a look at the source code. No, is it okay? Parsers. Well, it looks like it's kind of slow. Come on, why it's not okay? Oh, it was not slow. It was my bad. All right. So by the way, if you have never seen this what I'm showing right now. Oh, one second. This right here is the Toxygen's PostgreSQL documentation. Pretty good. They have done a great job, and I love it. They maintain it as well, and I hope this site never goes down, because it really helps me understand the source code and you as well. Anyway, so you can see, like, if you go to the SRC backend, there is, let's say, postmaster, okay, and startup.c, let's see, postmaster role, process main, okay, definition startup.c. The startup process initializes the server and perform any recovery actions that have been specified. Notice that there is no main loop, since the startup process ends as soon as initialization is complete. In standby, no one can think of the replay loop as main loop. Postmaster.c on system that PG interrupt. Yeah, mainly what I'm trying to do is I'm trying to find the code responsible for running the first process, like the master process, and looks like it should be under SRC backend. I think it should be one of these postmaster, but let's keep digging. Yeah, port window 32 signal. Atomics.c system window 32 and all these. Okay, partitioning. No, I think it has to be postmaster. Yeah, auxiliary processes. Okay, auxiliary process main. What is this? Function related to auxiliary processes, global variable. Yeah, the good thing about programming is the whole world's code can be described into 4 types, actually 3 type of constraint: sequences, loops, or iteration, I should say, and conditionals. Yeah, so sequentially you are running the code. There might be loops and there might be some conditionals. That's pretty much the whole, you know, the whole world of programming, I think. And that's what Dijkstra also recommended, that there used to be a goto as well, and goto was removed. So now it's just sequence of code which executes one by one by one. There might be some conditionals, or there might be some, you know, like here we have conditional, switch, 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 or otherwise it's just gonna be simple loop or sequence. That's it. Anyway, that's why it's easy to understand. That's why if you believe you can, I should say, that's why I think if you spend time on any code, you can understand it, because it's just gonna be that, irrespective of what language you are using. Okay. All right. Anyway, let's get back here. Background worker, sanity check. Background worker slot. This is very intriguing. BG worker. Fork process. What is this fork process? Fork process is simple wrapper on the top of fork. This does not handle the execute back. It might be. I think the fork process is the one which is, which should be triggered by the Postgres master. It forks a new process. I think this is it, and I'm not sure. That's what we are doing right now, trying to make sure. Okay, so fork process.c, a simple wrapper on the top of fork, wrapper for fork flash. By the way, if it is going too much detail, it's all right. You don't have to go into the detail to run a query, right? But here we are trying to understand, like have a full knowledge, and for that we have to spend time. Interrupt pgarc. What is this thing? pgarc postmaster.c. I think this should be, what is this? BG worker notify dead end backend type all exit start immediate shutdown max BG worker to launch. What is this? I wonder what is this. Is it the number of connection? 100. What is this? Oh, this program acts as a clearing. It is the time, if the time restart background worker as a side effect, no. Okay, let's go through the file. Like, let's start right on the top. Okay, I'm gonna use this. Okay, this program acts as a clearinghouse for requests to the Postgres system. Yeah, that's right. Front-end programs send a startup message to the postmaster, and the postmaster uses the info in the message to set up a backend browser. Nice. Yeah, we got it. This is the one. So remember, we are talking about this, the PostgreSQL master. In the source code, that the name, one second, okay. In the source code, the name of that particular, this particular process, which is essentially a C code which is run, is called, the name is, drum roll, let me use another, postmaster.c, okay, postmaster.c. So postmaster.c is mainly this program, okay, in the source code. What I was showing and we're gonna be taking a look into, let me get back here. The main process which you see running, which we are seeing like right here, remember we saw like this particular process which is running, which is, I think 1910 was master, and I think these other processes are the ones created by this master, so that, I think that's the case, but I'm not really sure. But I think 1910 is the main process, and what is the thing which is running? This postmaster.c is what is running by your Postgres program. Okay. This became very intriguing all of a sudden. All right. Uh, by the way, the chat is live. If you are here, anyone, say hello. If you have any question. And by the way, I do check your comments, and as if you have more questions, whenever I get time, I'm gonna think about it, how to solve your problem, and then answer it. Anyway, let's get back here. Postmaster. This program acts as a clearinghouse. Let me make it a bit bigger for you guys. This program acts as a clearinghouse for requests to the Postgres system. Yeah, it's kind of like controller, right? If you are coming from MVC framework. This program acts as a clearinghouse for requests to the Postgres system. Front-end programs, like these front-end program using JDBC or libpq drivers. This program acts as a clearinghouse for requests to the Postgres system. Front-end programs send a startup message to the postmaster. This guy, right? This code we are looking at. And the postmaster uses the info in the message to set up a background process. These processes, okay? The postmaster also manages system-wide operations such as startup and shutdown. The postmaster itself doesn't do those operations, mind you. It just forces off a sub-process to do them at the right time. It also takes care of resetting the system if a backend crashes. These are all really good points, and you know what? I am going to write it down in my engineering notebook. Yeah, if you want yours, you have in the description, you can buy that. So these are like really good points actually, and I'm gonna write here, but how do I write as well as have sequence diagram? Can I write here? Yeah, I guess so. I think you guys can see, right? Okay, so the postmaster.c. This acts as a clearinghouse for requests to the Postgres system. Postmaster uses the info in the message to set up. So the this guy, first what it does, set up backend process. Okay. Backend process to handle client request. Okay. Then secondly, what it does, it also manages system-wide operation. Sets up backend process for system-wide operations. Shutdown, I'm just gonna route shutdown as well as startup. And lastly, takes care of resetting the system. It resets the system if a backend crashes. My handwriting is so bad. Anyway, so yeah, this is like really good information. So the first is this postmaster.c is the one responsible for setting up the backend processes, spinning up this process which is going to handle the client request, setting up the backend process for shutdown and startup of your PostgreSQL, and resetting the system if the backend crashes. I am gonna give me some time, 1 minute, and I'm gonna write this down on my engineering daybook. Postmaster.c. Acts as a controller for all client request. It forks new processes, new backend processes to handle those requests. Okay, and lastly, uses the info in the message. Also it uses info in the message passed by client. Okay, and lastly it forks of subprocess to handle startup and shutdown. Also resets the system if a crash happens. Okay, all right, awesome. Give me 1 second. I need some water. All right, be right back. Yeah, all these details, I love it. I love getting into the detail of things. All right, let's get back to our exploration. So the postmaster process creates the shared memory and the semaphore pools during startup, but as a rule does not touch them itself. In particular, it is not a member of the pgproc array of backend, so it cannot participate in lock manager. Okay, so it also, this is important, it creates the shared memory and the semaphore pools during the startup. Also creates memory, shared memory, and semaphore pools, okay, during startup. That's awesome. Oh, that's awesome. Okay, but as a rule does not touch the postmaster is almost always able to recover from crashes of individual backend by resetting shared memory. Oh, this is also interesting. So to reset or to restart a backend process, the it resets by resetting the shared memory. All right, so now we also know how it does the resetting of a backend process like these, which it has four. This is very interesting. Maybe I should have like an email or something which says be right back whenever I'm taking a break. Yeah, I'm new to live sharing, so bear with me. The postmaster is almost always able to recover from crashes of individual backend. When a request message is received, we now fork immediately. Ah, this is interesting. So let's get back. Oh, oops, what did I do? Let's get back to our whiteboard. Okay. So it's saying, and yeah, okay. It's saying whenever this. So how does it create it? So it triggers. It calls this function fork. Okay, that's what the postmaster process creates the shared. When a request message is received, this is the request message, right? And then this is the fork. Maybe I should use a different color because green. We use green for client, right? So maybe I should use fork. Okay. We now fork immediately. The child process perform authentication of the request and then becomes a backend if successful. So then it here there would be an authentication. Okay. So in between these two phases, before it can serve as a server, it will authenticate client request. Okay, cool. Can you see? Or yeah, let me. I think for you guys I should write a bit bigger. Okay. Authenticate client request. Okay, and then it goes here. Okay, then it goes and does like response or something. I guess you guys can read now, right? Okay, cool. All right. So the child process performs authentication. Yeah, that's what it's doing. Authentication of the request and then becomes a backend if successful. This allows the auth code to be written in a simple single-threaded style as opposed to the certified poor man's multitasking code that used to be needed. More importantly, it ensures that blockage in non-multi-threaded library like SSL or PAM cannot cause denial of service to other clients. Oh. More importantly, it ensures that blockages in non-multi-threaded libraries like SSL or PAM cannot cause denial of service to other. Blockages in non-multi-threaded. Okay, my bad. Let me switch the window. I'm reading this line right now. More importantly, it ensures that the blockages in non-multi-threaded libraries. So SSL is mainly a non-multi-threaded. It's a single thread, single multi-process library. So it ensures that blockages, and if there is a blockage, it cannot cause denial of service. This allows the auth code to be written in a simple, single-threaded style. Oh. Auth code to be written in a the child process performance blah blah blah. This allows the auth code to be written in a simple single-threaded style. So the auth code, which does it mean the auth code written by client application has to be written in a single-threaded style? It ensures that blockages in non-multi-threaded library. Oh, I guess I think I understand what it is saying. So I think what it is saying is, since for each of the requests, right, a new process is run. A new process is forked. I should say fork, right? A new process is forked. Even if there are shared memory, if there is a blockage in one of these requests, since for every new request a new process has to be created. So this request, like let's say request number A, being idle, will not affect any new request from, let's say, client application number 2 to be received, because it's not a single threaded application. It's just gonna spin off a new process, totally new process, and if it is idle, then maybe the postmaster will destruct that particular process if it is, stagnant or idle. Yeah. All right, this is what I understand so far. But this is a treasure, right? If you understand, you know what I'm talking about, right? Like this is a treasure. It's like it's so like properly documented. It's just, that's kind of the way to document your code. Okay, this is nice. Okay, so now we have like all the libraries over here. Let's take a look at the fork process. I'm interested in the fork process. Define backend type normal, auto vacuum worker process, BG worker. Okay, so I guess these are all used for like different operations. The different operation which it performs, which is set up the first, like a spin off a new server, shut down startups, as well as reset the system. So I think these are mainly related to those. List of active backends. I'm talking about these constants. Okay. List of active backends or child process. Anyway, we do. As shown in this list includes not only blah blah blah. Okay, it's not special children such as startup, BG writer are not in this list. Type def backend. Okay. List of active okay, or child process. Anyway, we don't actually know whether a given child has become a backend or is still in the authorizer. This is used mainly to keep track of how many children we have and send them appropriate signals when necessary. If a set of backend, this list include only the normal. Okay, so this is the struct. Okay, so the backend process which we are talking about right here, which handles your request when you do select, select something, and actually before that, when you are trying to establish a connection to run, let's say you are starting a session in DataGrip, or your client application is invoking a request. So the first thing, the object type which handles authorization and runs your query is not the postmaster.c, which we already saw. It's this backend process. Okay, so let's write down this. So this is the backend process. I'm getting out of space so fast. And the struct, it's an object. All right, in C there is no real object, so we use struct, but it's an object, and the name in the source code is BKEND, and mind you, it's an object, okay, with some sets of properties, and this is it has code related to what you're writing, and then this is the one which this object is the one responsible for handling your request, what you are sending, handling your SQL, the SQL query you wrote. Okay, all right, so let's keep moving. So this has a PID, process ID of a backend. Awesome. Okay, so let's actually write down right here. Okay, so it becomes a bit more clear. So BKEND, okay. And backend has a PID, okay. Good. Then we have cancel key for cancels for this backend. I think it's more about administrative. PM child slot for this backend. Backend type, child process flavor. Huh. Backend type. So these are the backend type: normal, auto, vacuum, prover. Oh, wait. Wall sender BG worker process. Ah, that's interesting. I'm thinking when we run vacuum and all, is it handled by a different type? So the type, when we write analyze vacuum or system queries, I think the type is set right here. But this is interesting. Then we have dead end. Is it going to send an error and quit? And then we have gets BG worker startup stop notification. List link in backend list. Okay. And then we have backend type def struct backend. Oh, the struct is backend, and this is the object. Okay. If def exec backend blah blah blah. The socket number we are listening for connection int. It's an integer. Okay. The directory names for Unix socket. The TCP list. Okay. Reserve backend is the number of backends reserved for super user use. This number is taken out of the pool size given by max. Oh, this is nice. So where is the max connection defined? That is the connection I was talking to you about. All right, and I'm forgetting to switch the screen. My bad. So I was mainly looking into these. Okay, so postmaster and all. This one says reserve backend is the number of backends reserved for super user use. This number, this int reserve number, okay. This number is taken out of the pool size given by max connections. So number of backends available non-super users is max connection minus reserve backend. Ah, this is interesting. So super users can use all connections. Non-super users can only use max connections, which I think on Heroku I have experienced like 20 is like, I mean, in Rails application you can, of course, you can set it as per your plans, reserve. Oh, wait a second. So that means when Heroku provides us different plans, when you upgrade to a plan, Heroku or someone else is providing an add-on, what they do is they use the same driver, but on top of the driver, the code is specifying the max connection, which we are seeing right here, is upped or it's increased. That's the one it is, and that's why that's kind of why they charge us more money. Okay, but of course you need like maybe multi-core system in order to handle so many processes, and that's also why they're charging, because they're providing the machines on which all those processes can be run concurrently, right? So it means that the machine configuration available might also vary, although I'm assuming the machine configuration available to run these different tiers of your Postgres plan will also vary. That's my assumption. I'm not sure, and that's why they're charging you more money. But if it doesn't vary and it's just the code which is specifying 20 versus 40, I'm gonna be bummed out. It's like, that's not good. I mean, then what I'm paying for, like, that's fraud. Anyway, let's move further. Note what this really means is if there are reserved, like, okay, cool. But that's good to know that only super users can make new connections. Oh, pre-existing super user connection don't count against the limit. All right, cool. Reserve backend, PG socket, these global control the behavior of the postmaster in case some backend dumps. Normally it kills all the peer, blah blah blah. Okay, PID of these are not that important. Startup process status. So these are mainly status. Fatal error, false. We use a simple state machine to control startup, shutdown, and crash recovery, which is rather like shutdown followed by startup. Oh, so this is interesting. So what they're saying here, oh, looks like my flux is fluxing. Okay, so this is interesting. Look at this. So they're saying we use a simple state machine, like finite state, finite automated with maybe 3 states. Yeah, we use a simple state machine to control startup, shutdown, and crash recovery. So the code, how it works, in my opinion, is this. And yeah, it's and the whiteboard is all filled. Should I remove this, or how do I write more? Maybe I should bring it on the, on my notebook and my engineering day book, link in bio, and write others. Maybe I should do that. Yeah. Okay. So client application, and at the afterwards, I'm gonna draw everything again. Okay. Application. Then we have postmaster.c. Okay. Then you have backend process, and struct is bkend, which is also an object. So the client sends a request, which is good, and then the request, this is handled by using the fork process, and we're going to be taking a look at the fork. And then the next is authentication. Okay, and it's saying that, okay, all right, cool. So now we have authentication and everything. So I think I can delete this, although, yeah, maybe not. So what it's saying is, with respect to the state machine, there are finite states, and they're saying like there is a startup. Okay. Startup, then there is a shutdown, then there is a crash recovery. Wait, what? Which is rather like shutdown followed by startup. We use simple startup, shutdown, and crash. Oh, so it's actually this. These are 2 of the states: shutdown, startup. If there is a crash happen on shutdown, there is a crash recovery. Okay, so I guess the code which we are taking a look. By the way, what we are doing right now is mainly we are taking a look at the source code, right? We are trying to understand how postmaster.c, which is this program, the main program, which is we saw in our activity manager, right over here, this 1910, this is the main program. And threads, also check this. Sorry, okay, yeah, right over here, this 1910. Okay, this is the main one, and look at the number of threads they are using, right? So this this points to what we are discussing, that Postgres always allows one process per connection per backend process. So there is only one thread. Okay. Anyway, let's keep moving. After doing all the postmaster initializer, we enter PM starter state and the startup process. Oh, this is interesting. After doing all the postmaster initialization work, so where is the initialization? Let's see, is there like a defined initialize? I mean, these are all pretty much like variables and objects, static bull, but that's all right. Let's keep moving, I guess. So then after doing all the postmaster initialization work, we enter PM startup state and the startup process is launch. So there is an initialization work and then startup stage, which is startup right here. The first state begins by reading the control file and other preliminary initialization step in a normal startup or after crash recovery. The startup process exits with exit code 0. We switch to PM run state. However, archive recovery is handled especially since it takes much longer and we're like blah blah blah. When the startup process is ready to start archive recovery, it signals the postmaster. We switch to PM. Okay, this is more like intricacies of how the postmaster handles startup and and shutdown. By the way, if you hear noise, there is a train going on, so not my fault. Okay, we track these in the backend list. These might not be the normal. Oh, okay. This normal child backends can only be launched when we are in PM run or PM hot standby state. So when archive recovery is finished, the startup process exits with exit and we switch to PM run. Okay. So if there is a crash, then archive recovery happens, and then when we are in PM run state, so there are states of this particular, like postmaster.c. I think a normal child backend can only be launched when we are in PM run, okay, or PM hot standby case. In other states, we handle connection requests by launching dead end child process, which will simply send the client an error message. Oh, look at that. So normal child, if, okay, this is very interesting. And this is becoming more and more clear. I love it. I hope you do as well. So what this is saying, I'm gonna clear out this diagram a little bit so it's a bit more clear for us, and let me just remove all this extra stuff. Okay. All right. So what it's saying is, when the postmaster.c starts, it does its initialization or either in the startup phase, or if there has been a crash and the recovery is done through archive recovery. In that case only, a child process can be launched. Okay, if that is so, we should say like authenticate plus there. So fork if PM run, if PM run, okay. If this is the state PM run, which is the very the state of the postmaster.c, if PM run is true, let's say, or the state is PM run, in that case only this would be created, this backend process would be created. Otherwise, if not, maybe I should, how can I, maybe like if else, if it proceeds, yeah, I mean I'm mixing up two diagrams, I should not do that. But anyway, if it doesn't proceed and PM run state is false. Okay, in that case what happens, it's gonna send a response saying error. Okay, this is very interesting. So again, your client application, or you wrote SQL and you hit enter. The postmaster.c first of all was running, and it saw your request coming in. It handled the request at 5432 port normally, but that's default. And we already saw over here, if you remember, in the activity monitor, right? Where did my activity monitor go? Okay, so for example, this is the master process. Okay, postmaster.c, the main, that's what is running on this process. Okay, and then you have others which were created only when the PM run state was set to true, or the PM hot standby state was true. Okay, if PM run true, PM hot standby true, else error. Okay, so in only those cases, otherwise so in cases where PM run or PM hot standby state was true, like that was the state of I think postmaster.c, in that case only authentication would be proceeded and then response would be sent, or like whatever. If that's not the case, there will be an error sent back to the client saying, hey, something, like error, like this is not accepting this is not accepting connections, or error happened, or whatever it is. But the reason behind that is that if you're getting an error when you're running your SQL, it means the PM run or PM hot standby state is postmaster.c is not in those states. That's why. Okay, let's keep moving over here. All right, so in other states we handle connection requests by launching dead end child process, which will simply, okay, so in cases where it's not PM run or PM hot standby state, then it will launch dead end child processes. Look at this. Okay, I think we saw this dead end in the here. Where was that? Child process flavor, backend type, dead end. Okay. Did I see dead end somewhere? I think I saw dead end somewhere. Oh, also dead end. Right there. Okay, see that. So by the way, we already established that this struct, this, or just think of it as an object. This object is the one responsible for running your SQL. Okay. Postmaster.c, this file, creates an instance of this particular, creates an object of this particular struct. If the bool and if PM hot standby or PM run state, or the postmaster.c is in that state, then it's all gonna be good. Otherwise, this bool is gonna be set to true. Is it going to send an error and quit? So the mechanism of sending a response back as error is to, I think it's to set the boolean as true, and then based on the boolean there would be another this would be termed as a dead end child process, and it will send a response to your client application. All right, let's keep waiting. Sorry, not waiting. Let's keep moving. Where were we? Okay, right there. All right, cool. In PM wait dead end state, we are waiting for all the dead end children to drain out of the system. This is interesting. We track these in the backend list so that we can know when they are all gone. This is important because they are still connected to a shared memory and would interfere with an. Okay. In PM dead end state, we are waiting for all. By the way, I'm looking here, but it looks like I'm looking over there. But that's how my setup is. In PM wait dead end state, we are waiting for all the dead end children to drain out of the. Okay, this is just operations intricacies. Notice that this state variable does not distinguish why we enter states later than PM run. Something. Okay, cool. Postmaster starting. So this enumeration is for postmaster itself. I see. I mean, this enumeration is used for postmaster itself. Something. But yeah, this is like all the functions postmaster.c utilizes. Close server port and all these. This is nice. I love it. Yeah, I always love going into that, all the detail, trying to understand how things actually work, and it's just awesome. Postmaster state machine. Oh, what is this? Let's take a look. Oh, come on. We were there. What the fuck? Okay. You gotta be kidding me. Alright. Come on. So we were like around here, right? Okay. So these are all the functions. So you see, it's all function. It's encapsulation, which handles whatever, like how the postmaster.c works, which is again the main process, which is again this 1910, which is the main Postgres. Okay, I think. Reset shared, something dummy handler, cleanup backend. There are a lot of processes, and there are a lot of functions, and these are pretty much the ones responsible for running all different cases, starting up, terminating children, and all this stuff. But yeah, this is mainly related to operation. I'm trying to find out what we are doing right now is trying to filter information which will tell us how exactly a query is handled. Okay, so far we have established this chain, right? Client application sends postmaster.c that handles it. If the state of postmaster.c inside is PM run, then the the backend process would be created, and that backend process would do an authentication, and then it will be ready for handling your SQL code. Okay, so we don't have to necessarily go into each and every function, but just for taking a look, we could just go to postmaster.c. This is the state machine. Okay. And remember, we are talking about the state machine where we had two states, and one the one which was handling the error between start and stop. If you're doing a smart shutdown, try to advance that. If PM state equal to PM run, if cons allowed, allow cons connection state ends as soon as online. If not, backup allow no cons. If connection equal allow no cons state ends when we have no normal client backend. Then I see. Okay, this is interesting. If you are ready to do so, signal child process to shut down. And this is like all the child process handling. If you're in a state machine state, that implies waiting for backend, okay, to exit. See if they're all gone and change. Okay. If PM state PM shut down. Oh, actually there are more states here. Technically, there's PM wait dead end, then there is like this PM wait backends and so on. Okay, I'm trying to find out what is the one responsible for, you know, creating the children. If we have been told to shut down, we exit as soon as there are no children. This is all like, this is all about termination. Okay, it's fine. I guess. Let's keep going, let's see, keep going. What is this? In the postmaster we use PG signal PM rather than PG. Except on Windows we tell child process will generally want as a restart server or something convention in this list. Something and OPT parse command. This keep this in sync with, okay, this is all like operations. Postmaster accept no options which, okay, create log file for data directory, all these, okay, these are all operations pretty much like ops related. If you want you can take a look into it, but I guess it doesn't, you know, relate directly to the successful running of your SQL. But okay, let's take a look. Read a client startup. Oh, look at this. Read a client startup packet and do something according to it. I think it was the authentication. Return status okay error or might call. INT32 protocol version memory context. Grab the first byte of the length word separately so that we can tell whether we have no data at all or an incomplete packet. So it checks for, so this one Postgres is checking if there is an incomplete package, which makes sense. Like, you know, this might sound ineffective, but it's not really because of buffering in program.c. Interesting. PG white got a partial length word, so bleat about that. Allocate space to hold the startup packet plus 1 extra byte that's initialized to be 0. This ensures we will have null termination of all. The first field is either protocol version number or a special. Okay. No SSL when disabled or on Unix socket. Okay. You've sent port sock, blah blah blah. Yeah, if it is too complex, don't worry too much about it. We don't have to understand everything. We just, you know, we are just trying to get an overview, detailed overview, okay, which the documentation is not providing us. A regular starter, documentation on like this documentation, okay. Regular startup, this is no. Front end. Now fetch parameter out, okay, now here it is fetching that. So this was all like, what's the word I'm looking for? Bookkeeping? No, housekeeping. Yeah, housekeeping. These were all housekeeping. Now fetch parameter out of the startup packet and save them into the port structure. Old content, memory context, blah blah blah. Handle protocol version 3. All data structure attached to the port struct must be allocated in top memory context so that they will remain available, blah blah blah. So it's like they have a struct, or I should say object, for port as well. Handle protocol, int size of this, scan packet body for name option. We can assume any string beginning with blah blah blah, while offset is less than length. Found packet terminator. So this is mainly looking for the packet which the client application sent, the network packet. If it's a database due to back, else it's options. Due to backend compatibility concern, the replication parameter is a hybrid beast. Okay, so this is mainly handling the packet. Okay, if you didn't find a pop, check a username was given. Oh, so this is also checking the username. Okay. Otherwise, it will return. Ah, no Postgres username specified. So when you do, when a client application sends a request, it also has to send the username on behalf of whom the request was made. That's interesting. The database default to the username, otherwise it is defaulting. Okay. If the DB username, if user add, it is a global user, remove add. We only want to do this if there is an okay. Wall senders backend. I have no idea what is that. Connection due to database state. So now instead of waiting cycles, CAC send a negotiate protocol version to the client. This lets the client know that they have requested a newer minor protocol. This is very detailed. The client has sent a cancel request packet, not normal. Perform the necessary, but nothing is sent back to the client. So in case we cancel the query, this is how it's handled. Like I ran the query and suddenly I hit cancel on data group. Then I guess this part is the one which is gonna handle. Hello, Moto. Give me 1 second. Hello, Pa. All right. My dad called, so I had to take it. Anyway, let's keep moving. Can accept connection. This is all pretty much like the intricacies of it, and I guess we don't have to go in. Okay. We rely on comments, normal operation, crank up the background task. If we didn't do that already, was it wall receiver, scan the BG and see. Okay, these are all like internal where housekeeping. If we have been told to shut down, we exit as soon as they're. Yeah, these are all. Holy shit, that's. Okay. Process background worker state. Yeah, I think these are all pretty much, you know. These are all the function which were the prototype were defined up. Replicate a socket for user. Yeah, these are all like pretty much your all codes related to operations of the postmaster.c, which is the one responsible for invoking invoking a new backend server, which is itself is a process handling another code, and that is the one which is gonna handle your code. Okay, that was a lot of details. So a connection from an application program to the Postgres servers has to be established. The application program transmits a query to the servers and wait to receive the result sent by the server. And the parser state checks the query. Okay, so today we took a look at the connection. All right, let's recap. All in all, we did proper, thorough, in-depth analysis of what happens. So we understood that postmaster.c file is being run on the master process, okay? And postmaster.c is the one responsible for forking a backend process which is mainly of the type bknd, which is a object of that struct. But C doesn't have objects, so it's an instance of that particular struct. Okay. That backend will that process that particular that backend process will only go through if PM run, in usual cases PM run in the postmaster.c, the state PM run is the state is PM run or PM run is true. Okay. If it's not true, in that case this backend, this process, the dead, remember the dead child, dead child. Let us see. I'm forgetting the name. Dead. What was the name? Dead end. So this boolean dead end in this particular instance will be set to true. Okay. And if it is a dead end process, that means PM run currently is not the state of the postmaster. Maybe it's doing, maybe it's not accepting. Maybe it's in the, it's not in the start, it's not in the running state. Maybe application crashed. Maybe it's trying to restart the application and so on. But the most important thing to remember is PM run is not set to true. In that case, the dead end boolean will be set to true, and if the boolean dead end is true, then this particular process, the backend process, will send an error response to the client application. We also saw there are a lot of, if you want to explore, there are a lot of different functions for handling different kind of edge cases and edge cases. So if you cancel, if a client application cancel the request, then how to handle that? There is code for that and so on. And there are a lot other which, for the sake of tracing your SQL, might not be that important. Okay, but it is important if you want to understand everything, but every case. But for the right now, we are focusing on tracing how your SQL is going to be implemented. Anyway, if the dead end is false and the PM run is the state for the postmaster.c for the process, that means a new process would be created, would be forked, and that would do an authentication based on what packet the client application sent, and based on the authentication, that which user is the user authenticated, the the password, the username, and based on that, then it starts with the next stage, which would be parsing. Okay, only then it goes into that. All right, one more thing I wanted to see is the fork. Is there like fork? Okay, this fork process. All right, fork process. Look at that. So right here, PID, exec backend, child. If PID is 0, this, which is this one, backend startup, start. Okay, this is the good. So I should. This is the one, the backend startup. It's still in postmaster.c, is the one I think which is responsible for starting the backend process. Remember this process, spinning the one with which is forked. So what it does is, it's mainly a function which has a PID, create backend data structure. So backend, okay, we already saw the backend had, there was a data structure, the struct, which had like multiple fields, PID, dead end, true, boolean, and so on. That's what it is creating right now. If not available, then it is out of memory. I see. So if it cannot create that struct, create backend better before the fork, so we can handle failure. Okay, so it creates that so that in case the error happens, it can use that as a dead end child process and throw the and send a response, an error response back to your client application. Compute the cancel key that will be assigned to this backend. The backend will have its own copy in the fork or blah blah blah. If random cancel, okay, pass down, this is not in, this is not, okay, right here. If def exec backend fork exec port, else PID is fork process. I think this is the one responsible. There's a detangle from the postmaster, close the postmaster socket, perform additional initialization and collect startup packet. Okay, the packet passed by the client, and backend run the backend. Oh, this is interesting. Exec backend. If PID is less than 0 in parent, release postmaster. Backend successful. Try to report backend. Okay, this is interesting. Backend run. So first of all, there's a fork process which would be forking the process, and we can take a look into it. But I'm more interested in the backend run. What happens in the backend run? Like what exactly happened? Wait, what? No, I said okay there. What is the definition of backend run? This suddenly got very interesting. Okay, come on. What? Backend run? Okay, right here. So backend run, it is passing the port of that particular child process, right? So PID is returned from the forking, which is this program fork process, I think, and free detangle, and then it is passing the poke and run the backend. Okay, just keep digging. Set up the backend's argument list and invoke Postgres main. Oh, this is interesting. Okay, so what is this Postgres main? I am very intrigued. So it is saying that after this, not the parse, it's calling another one, which is the method which is called is invoke Postgres main. If everything is successful, if it is not successful, it will throw in like set the dead end boolean to true, or there are other errors, and at the end of it, it will pass that particular error as a dead end dead end process. But if everything went through, then it's saying it invokes the what it does, Postgres main. Okay, so number one, We have number 2. Actually, this should be number 2. Then we have number 3 or 4. And if it is not error, then we have number 5, which is your SQL, whatever SQL you had, now is in here. And Postgres, I think Postgres main is gonna handle it. Let's take a look. Let's see if we are right or wrong. Okay. Set up the backend argument list and invoke Postgres main. Okay. This is just setting the backend run Postgres null. Make sure we are not in postmaster context. We can't delete it. Just okay. Post exec backend. Postmaster fork exec. Backend fork exec. Internal fork. Okay, these are all like fork exec. I'm more interested in Postgres main. Okay. Where do I? Postgresql.c. Oh, now we are talking. So this is where this is the next orchestrator looks like. Okay, Postgres main. What is this? Postgres.c. Postgres C backend interface. So this is the one. So now a new process was invoked. You know, there were all kinds of bookkeeping and things like that happening, error checking. But now this process is gonna run Postgres main. All right, and let's take a look into this program, which is Postgres main. So this is the one which is gonna handle your query if everything is all right so far. Okay, so far there might be more errors. So let's start taking a look here. This is under tcop under backend, still on the backend. Okay, cool. Global variables, something. What I wanna check for Postgres single and routines using Postgres main. Where is Postgres main? I wanna see. What? Oh, it might not be. Okay, there we go. Postgres main loop. All backends interactive or otherwise start here. ARGC, ARGV are the command line argument to be used. Oh, when being forked by the postman, these are not the original ARGV array of the process. DB name is the name of the database to connect to, or null from the command line. Username is the Postgres user. Okay, cool. So what it is doing? So we have ARGC and all these things. Username, it's taking the username and the database name. Okay. First char, first character, input method, local, something. I'm not really sure what is this. Volatile, send ready for query, initialize startup process environment if okay. So it is startup environment it's starting first. Then set default value for command line option. Okay, parse command line. Oh, now it is parsing the command line. Must have gotten a database name or have a default the username. Okay, if database name is null, then database name is the username, or acquire configuration parameter unless inherited from postmaster. Set up signal handler, something. Postmaster blocked all signal before forking child process, so there is no race conditions. That is all bookkeeping book. It is not best or something in a postmaster child. Validate, we have been given a reasonable looking data directory. Oh, PG signal. Okay, initialize timeout. Okay, these are all like, I think these are all error handling. Let's move further. Is not under postmaster. Check data direct. Check into data. Check create log file. Read control file. Create a per backend PG struct in shared memory except in the blah blah blah. Early initial base init Postgres. If you are tempted to add code in this business, consider putting it inside here instead. I think this looks interesting. The postmaster context is still around. Excuse me. Welcome banner for standalone case. Create the memory context. Let me put it on disturb. Do not disturb. My bad. Create memory context. Okay. Postgres main processing loop started. If an exception is encountered, processing resumes here. So we abort the blah. You might wonder why this is not coded as an infinite loop around a PG try construct. The reason is that this is the bottom of the exception start. So blah 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 blah. If signal set jump is not equal to, if you're tempted to add more code in the if block, forget any pending query cancel request. Since we are returning to the idle loop anyway, and cancel anytime active. In future we might blah blah blah. Doing command, make sure libpq is in good state. I'm trying to find like where exactly is the the SQL pass, what you wrote. Where is the parser triggered? That's what I'm trying to understand. That's what I'm trying to find. We will find it. So I want to clean up temporary slots. These are all bookkeeping. If an error happens, we can now handle error. Okay, I don't want to handle error. If ignore blah 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 for, that's an, okay. So there is an infinite loop. It looks like none error queries loop. None error. Okay. At the top of the loop, reset extended query. So in a loop, is it waiting for you to run your query? Is that what it's doing? Yeah, it looks like that's what it is doing for like, yeah. I'm gonna do a Google search on this for infinite I think it is an infinite loop. Okay, yeah, right there. Okay, so this is an infinite loop. Alright, so this is what is happening in an infinite loop. It is listening to your, like, it has established connection, and now it's gonna keep looking for new messages. I think new queries. That's what my assumption is so far from our research. Okay, let's keep moving. Doing extended query, memory context switch, something. Also consider releasing. If you reach idle state, tell the front end we are ready for a new query. This is also a good time to send collector statistics to the collector and to update the PS. You avoid doing those every time, blah blah blah. Start the idle, enable timeout. Okay, send out notify. Allow asynchronous signal to be executed immediately if they come in. Doing command read. Wait. Read command. Is this what I think it is? Like the command you have provided first jar? Input message. Oh. Looks like this is your SQL. Is that right? Where was I? String. Oh, so this is your. Is this the input message? So far I feel like this is the input message which is passed by us, like you or us. Read command, okay, and this is like the, I think it's address of that or the contents of that. Query cancel is supposed to be if ignore switch first case Q, simple query. First is the command bucket ignore set current statement query string pg get something pg get msg message send. Oh, simple query parse. This is the parse stage. Then bind execute fast path function called close describe flushing. Oh, I think this is what we wanna. This is the jackpot. I think so. Let's see. Case Q is simple query cons query string. Okay. Set this is like statement times query string PG input PG something if I'm on if not exec. Oh, exec simple query. What is this? What is this exec simple query? Is this the one? But how can it execute without parsing? I don't understand. Parse tree list, save log, report query to various monitoring. This is drop something memory blah blah for each. Oh, run through the raw parse tree. So it says parse tree is already created and process one. Okay, now I'm confused. Simple query. Or maybe it's just maybe it has nothing to do with the sequence of how it's written. Okay, so in that case parse would be the first. Set statement pg get this, query string is this, number of params, pg get, okay, if number of param type is palloc. I think palloc is, it's gonna assign a chunk of memory. Okay, let's take a look into palloc. I have used malloc before, but palloc, I think malloc. Yeah, hands out smaller chunks. System memory divided into two pools called kernel. Yeah, and versus. Yeah, I have used malloc before. Use palloc in our code to allocate memory. It is okay to use palloc, but hey, let's take a look here. Palloc gives you a 0 initial while malloc leaves the memory uninitialized. Palloc. So all in all, it's mainly looks like yeah, I think all in all it only assigns a chunk of memory and then we can do param types. For int our number is 0, param types pg I input message. What is this? It's coming time and time again, you know. I want to see what is this guy. pg get exec parse message. Ooh, this is very interesting. What is this exec parse message? First of all, what is this pg get msg definition at this line 417? What is this? Get a binary integer from a message bus buffer. This will maybe not that important. It is important, but not for current case, which I have in mind. Let's go to execute a parse protocol message. Oh, so this is the one which will execute a string to execute name for parameter, number of parameter. So this is the one which will execute the parse, like hey, go and parse this message, the SQL you have passed. So then it will create parse. Yeah, I think that is the get report query to blah blah blah, start if name, parse tree list. Yep, I think this is the one. So as much I know, the next step in the process is normally the parser. Okay, the parser is a parser.c, which is a separate another code, which is where it looks like it's taking this all the your message as a string, okay, string, and it is passing it to the parser, or mainly it is invoking the parser method, which is gonna create the parse tree. I think so far that's the way. But yeah, this is very interesting. Palloc And yeah, you see exec query string is right here. This is your query string, okay? Yeah, and this is the parse which is gonna invoke the parser, okay? Yeah, looks actually, yeah, this one, query string, okay. Where is the query string? I wanna see. No, not, where's the query string? In the parse, yeah. From my understanding, parse is the one which should be called, okay? So why am I not able to select this? Okay, there we go. Query string, query string, query string pg get message string. Okay, let's take a look at this method, okay? I think this is the one gathering the string. Get a null terminated text string with convert may return a pointer directly. Okay, get a null terminated text string. So it's gonna be terminated with a null text string. May return a pointer directly into message buffer or a pointer to a palox conversion result. Okay, okay. Yeah, it looks like, so it is gathering, it is taking the message which is your the input message, and the input message is coming from, input message would be coming from the packets from, you know, like the client. Input message, let's also search for input message right here. Okay, I'm trying to see like how is it passed, where is it passed the first time. God damn it. That's like, okay, input message. Okay, so input message is exec bind message, and this was the one we saw. Exec, okay, this was the one which we saw in the, let me do one thing. I think we saw it in the postmaster, right? Postmaster.c. Yeah, I think postmaster.c was calling this and passing the input message if everything was all right, right? So let's go here and search for this. Yes, go to the source code. Oh, so this was calling the Postgres run? No. Postgres run. Okay. Exec bind message. Okay. Oh, come on. Where was that? Now I got confused. A little bit, but we'll figure it out. Yeah, I'm trying to get to the Postgres in like where it is invoked. Yeah, that's gonna take a long time though. Where was this called? Exec parse message. Yeah, I think this was the one being invoked, right? Oh, my bad. this was calling the fork process, right? I think, and the fork process was calling this. No, whoops. Okay, I'm kind of losing. Where was it? All right, let's trace it. Exact parse message, where it is invoked. We can see the tree. Yeah, I'm kind of. So the backend process, it ran. Oh shit, Postgres main. Yeah, okay. That's what I was forgetting. Postgres main, it's called. Postmaster, okay. Postgres main. Backend run, right? And the backend run was set up the backend argument list and invoke this. Okay. Backend run. Oh, there we go. Phew, okay, so Postgres main is the one invoking this one, right? Postgres right here, Postgres main. So let's search for Postgres train again. Postgres main. Okay, so yeah, Postgres main is the one here. Okay, so postmaster invoked the Postgres main. Postgres main came to where? Postgres.c. I should write it down. Yeah, not parser.c. Postgres.c. Okay. Postgres.c, and this is the one which is gonna invoke. Let me also write down here. Postgres main, and then we have Postgres.c, and this is gonna invoke the Postgres main. It's gonna invoke the exec, right? Exec. Where was that? Exec parse message. Okay, so this is gonna do the exec parse message, and let's take a look at the exec parse message. So this is then doing an exec parse message. Okay, this is invoking that for parsing. Okay, and the case is over here, first char. Exec parse message is the one we need. Okay, and this is defined here. Execute a parse protocol message. We have two strategy: if name, drop a name, memory context switch to PG parse. Do basic parsing of the, okay, PG parse query. This should be okay. So now the parsing stage started. Okay, so this one, now the parse stage has started. Okay, now your query was passed as input message, and finally that triggered this one, exec parse message. Exec parse message triggered, where was that? Oh, come on. PG parse query. Okay, yeah. So this PG parse query is like the one which is gonna do the parsing. Okay. A list of parse trees is returned since there might be multiple command in the string. Yes, This is what I'm talking about. Trace, Postgres, query parse, blah, 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 given a raw parse tree. And then there would be like, now for the parser, we would be thinking about analyzers. Next part of this video about parsing. We'll take a look into, Bison, as well as, I think it is Flex. Yeah, Flex or something like that. Analyzer and parser, which is used by Postgres. But yeah, so far so good. We got pretty far today with the parse tree list. So this is Postgres main. This is gonna call exec parse message, and then that is gonna call PG parse query, and that is parser. Awesome. Okay. We only allow a single user statement in a blah blah blah. Okay, so I'm gonna stop right here. I think we made pretty good progress. If we go back to here, we already did a lot of investigation into the first, how the connection is made, what are the parameters. Remember, if only PM run state is available, then this backend process would be proceeding with parsing your query. If not, it will throw an error right away. So these things are more clear to us. And next is parsing stage, which will check the query transmitted by application of a current syntax and create a query. So in next live session, we will be taking a look into parse stage. And we already started, so the PG parse query is gonna be the one which is gonna start the parsing. All right. So I really appreciate you guys over here, or if you wanna watch it afterwards. In the next video, we're gonna be taking a deep dive into the parsing stage and how Postgres does it. So far, your query which you provided to Postgres, when there was a new process created, that process first check if everything was all right. If everything was all right, there was no error. Then it went through postgres.c, and the process was running the postgres.c file, and it then invoked the exec parse message, and that invokes the PG parse query, which is gonna build a parse tree for you. We'll take a look into it, that detail, but this has been really fun. Okay, I appreciate you guys over here. By the way, I'm also noting it down over here, so you can see I still have a lot of space, and that's why I like this. And again, shameless promotion, I created it for my own need, since I like things to be longer, especially when it comes to engineering drawings. Also, if you are not a member yet, I would suggest you should visit Teach Me Database, and you should subscribe to the newsletter. As we progress further, I publish tips and tricks and notes, and if you're a subscriber, you will receive it. And hand in hand, there are some of the content which are only like code which would be utilized in a video. They are only available for the subscribers. Okay, so yeah, subscription is free. All you have to do is go subscribe over here. Also, if you like this video, if you like this pairing session, leave some comments. Let me know if you enjoy this video format, if you like this to be real, unedited way to understand Postgres, or you want me to go back to the older way. But for me, this works because honestly, I hate editing. Anyway, thank you for watching. Take care.